When you talk about NFC, you probably thought of making payment like Google Wallet, Samsung Pay, or Apple Pay that are quite hot in the market currently. But another popular uses of NFC is to interact with a tag to retrieve any kind of information. Example of that is business card and smart poster, and there are a lot more uses of NFC which you already know. But as you might wonder, how NFC achieve all of this? Or the close in the name itself, NFC stands for Near Field Communication, which can establish a peer-to-peer radio communication. So passing data from one device to another by placing two NFC devices close to each other. Which means that it is possible that we can control various components such as LED on temperature, heater, sensor through your smartphone. And that is the main purpose of our video. And we're going to start our video on controlling just the LEDs on a microcontroller by using NFC. So I'm going to start off by showing you just the details on how the things work. So first up we have a STM32L053R8, which is a 32-bit microcontroller by ST Microelectronics. This MCU will serve as a control station to control all the components like LEDs, touch sensor, temperature sensor, and so on. But because the microcontroller didn't have built-in NFC compatibility, so we need an NFC expansion board, and it's called X-Nucleo NFC 02A1 that is based on M24LR04E. And that board itself is sitting on top of the STM32 MCU and thus enable the MCU to communicate to others NFC device. The location of the LED is around here, and the name of the LED for coding purposes is as follows. Now, we're going to look into the theory part on how the NFC expansion board receives the NFC data and how the microcontroller is going to retrieve the data back to itself. Now imagine you have a smart business tag and you put it near the NFC receiver in your board. And then the next thing that happens is the data in the tag will load into the memory, or technically we call EEPROM of M24LR04E. So the memory is now contain your data. And then the next thing that you can do is to call the STM32 microcontroller to read the EEPROM of the M24LR. Then you have the data of the tag, and it's simple as that. So up to this point, you probably have the idea on how to control components that are attached to the MCU. Next, to turn it on or off the LED, next thing that we should do is to define the bits for the four LEDs respectively. The M24LR04E contains 4 kilobit memory, I believe, and we're only going to use the first byte of the memory. Define the first bit to be LED 2, second bit to be LED green, third bit to be LED blue, and fourth bit to be LED orange. And the rest of the bit, we left it untouched. Now, the operation of controlling the LED is almost the same as the business card situation we mentioned just now. Now, let's assume we have coded the microcontroller in such a way that it will check the 4 bits that I mentioned just now in an infinity loop and turn on or off the LED based on the current status of the bit. If, let's say, we write the second bit to be 1, what happens is the microcontroller will find out that the bit has value 1, and it will turn on the green LED because we define green LEDs in the second bit. You get the idea? Alright.